Alright class, this will be a pretty short podcast. We're basically looking at protons, electrons, and neutrons. So here I'm just going to write this, protons, electrons, and neutrons. And we're just going to talk kind of about their properties, where they are, what their charge is, what their purpose is, and so we're kind of going to make a, I don't know, I call it a T-chart, but we're going to have several different categories. We're just going to make a table. So charge, location, mass, and what they're good for. So just going kind of like that. So the first one we're just going to do is charge. So what charge? That's really weird with my ink. Okay, so charge. Protons have a positive 1 charge. Electrons have a negative 1 charge. And neutrons, by their very name, neutral, are neutrally charged. So to have a charge of 0, or if you want to say neutral, whatever you want to do there. Next thing we're going to look at is their location. Alright, so protons are found in the nucleus. So that is the part of the atom that is credited to Rutherford for finding with his gold foil experiment. And we're going to skip down here as well. Neutrons are also found in the nucleus. And electrons are found in the electron cloud. So they are outside the nucleus, kind of orbiting around the nucleus. Alright, but they're in the electron cloud. And it's just the area outside the nucleus, kind of the outer reaches of where the atom kind of starts and where it ends. Alright, so the next thing is charge, location. We want to know their mass as well. And for this we're going to just do approximates. So protons are approximately, so that's a little squiggle just means approximately, they're approximately 1 atomic mass unit, or 1 AMU. Alright? Same thing with neutrons. There are about 1 AMU. Neutrons are just a tad heavier than protons. But on a test question, just know they're about the same, and they both weigh about 1 AMU. They are about 1,600 times heavier than an electron. So an AMU is very, 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 very little mass itself. So electrons, we say, basically weigh nothing. Alright? They do have a little bit of mass, but it's extremely, 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 it's extremely small. So again, protons and neutrons both weigh about 1 AMU. Neutrons are a little bit heavier than protons, and electrons basically weigh nothing compared to protons and neutrons. So charge, location, mass, and then the last thing is going to be their purpose. What we're going to find out is protons determine the atom's identity. Determine identity. So depending on how many protons an atom has, depending on how many it has, it determines whether it's hydrogen or carbon or neon or oxygen or whatever element it is. So if it has 1 proton, it is hydrogen. If it has 2 protons, it is helium. And the atomic number is the whole number on the periodic table. So the number of protons is what, count the number of protons, how many protons you have, is what element we're talking about. Electrons determine reactivity. So how dangerous a chemical or how dangerous an element is, how reactive it is determined by not only the number of electrons, but where those electrons are. So again, electrons determine the reactivity of a given element or a given atom. And then neutrons, again, neutrons are next to the protons in the nucleus. The nucleus is an extremely, extremely small space within an atom. So for hydrogen, this isn't an issue because we have 1 proton. the atomic number is 1. For helium and every other atom, there's at least 2 protons. And that is an issue because protons are positive. Opposite things attract each other, but similar things with the same charge, so protons are all positive. If you put them close together, they're going to want to repel each other and get as far apart from each other as they can, which inherently means they want to break up the nucleus. If we don't have a nucleus, all we have is the element hydrogen, but we have lots more elements in the universe. So neutrons, think of them as the glue that holds the nucleus together. Their presence in the nucleus, so we're going to say glue for nucleus, it overcomes the repulsions that the protons have for one another, and they really help the nucleus to not just completely fall apart, and they allow for elements other than hydrogen. If everything had one proton in the nucleus, every element would be hydrogen, but we have lots and lots of other things. So again, just a summary, know the differences between protons, electrons, and neutrons. Protons have a positive charge, electrons have a negative charge, neutrons have no charge. Protons and neutrons are both found in the nucleus, electrons are found in the electron cloud. The mass of protons and neutrons is basically 1 AMU, where electrons basically have 0 mass. They have a small mass, but it's basically 0. And then protons determine an element's identity, or an atom's identity. Electrons determine an atom's reactivity, and neutrons are the glue that holds the nucleus together. And that is it.